Sign diagrams example 2. We want to sketch the curve y equals x plus 1 over x, showing the coordinates of any stationary points. So while y is equal to x plus x to the negative 1, so dy dx is going to be 1 take away x to the negative 2, or 1 take away 1 over x squared. Now we're interested in that being 0. So 1 take away 1 over x squared is equal to 0. So 1 over x squared is equal to 1, which means x squared is equal to 1, and therefore x is equal to positive or negative 1. Now if x is equal to 1, y is equal to 2, so we've got 1, 2, and if x is equal to negative 1, we've got negative 1, take away 1, so that's going to be negative 1, negative 2. So we know that that's where our turning points are. Now, let's do a line. Well, first of all, I can see x is 0 cannot be substituted into this because we're dividing by 0 here. That's called a pole or a discontinuity. And you indicate one of those on your diagram with a dashed line. Then we know that the gradient will change at negative 1 and 1 because that's where our stationary values are. So let's look at to the left here of negative 1. So here's my expression for dy dx. Let's say that x is negative 2. So negative 2 squared is 4, so I've got 1 take away a quarter, that's positive. Let's take x is negative a half. Negative a half squared is a quarter. 1 divided by a quarter is 4. This is 1 take away 4, which is negative 3, so it's negative in there. Now let's take a half. Well, it's exactly the same calculation. When we square a half, we get the same as when we square negative a half, so that one's going to be negative. And then if we put 2 in here, 1 take away a quarter, so that's going to be positive. So, here's x and y. And we know that this is going to be a vertical asymptote, it's a discontinuity. There's a turning point at negative 1, negative 2, which is, let's say, just here. To the left of that, the gradient is positive, so it must come up towards that. Then we have a negative gradient, so it must go down. And remember, this is an asymptote, so it's going to go down the asymptote like that. We have another stationary point here at 1, 2. Let's just label this one, negative 1, negative 2. And this one's at 1, 2. To the left of that, the gradient's negative, so it must come downwards towards this. And of course, it's coming down the asymptote. And then we have a positive gradient after the turning point, so it's going to go upwards, like so.